This is Domo, Arigato, Mr. Roboto, security robots a la unit testing. If you're looking for some leet exploit drop, that's not what I'm talking about here today from the description, right? We're talking more about software security and how we can build security into our software. That's right where my expertise lie. That's what I've been doing for a number of years, and we'll get into it. But don't expect me to write some reverse engineering exploit right now. That's not my specialty. It's more about software testing, right? Hence the title and where that fits. But first of all, let's go through some introductions. Only a couple months ago, I got this response on Twitter, right? Somebody I was going to meet at one of the local B-Sides events tweeted at me and said, hey, it's going to be fun, but I can't unsee you as anyone other than the dad from Mr. Robot. So we're just going to have a little demo here. I'm the one that's on the left side if you're looking at the screen, not the one on the right. Again, hold on if I can get there we go. That's me. Seth, not Seth, all right. Okay, all kidding aside, my name is Seth Law. I'm actually the Chief Security Officer at a small application security consulting firm called Envisium. We're an Amazon partner. We do a lot with Amazon. But in general, we focus on application security. We focus on building secure software. All of our guys are developers. I'm an ex-developer. I actually started my career at iOmega. Does anybody here remember the zip drive? Hey, good. Okay, I was not responsible for the click of death. If you lost data, that was not my fault. I was doing the web development, not actual engineering development on that. But that's where I cut my teeth. I did some Java development for them. And then I moved more into the security space for a number of years and did security tooling, and finally became an application security consultant at some point, worked for a bank. And that's where I kind of got into the whole, hey, we're going to do a penetration test and look at it, and then started to work with developers on how to secure their software. I've previously presented at Black Hat USA on mobile application security. So there was a Sierra tool that we wrote, and this was 4 or 5 years ago, with some sort of automated assessment of mobile applications. And then also response analysis and further testing, so more web application security stuff. But since then, I've gone more the development route than just the pure security assessment route. And we can talk about those tools if you want to. If you've ever heard of the Raft word lists that are used in a lot of tools for fuzzing applications, I'm involved in that project still. That's Raft. But the tools themselves aren't as developed as they were back when we initially released them. It was a lot more research projects. But hopefully the tool that I'm going to release today, this Sputter, will be useful to a lot of people, right? That's the whole idea, but it's definitely useful to us and to me personally. Finally, I'm a soccer hooligan, right? I really enjoy soccer. I know that's not that strange outside of the U.S., but it does define me somewhat in the United States. I tend to follow the Premier League and the Bundesliga. So if you want to talk about Leicester City and what happens, right, we can do that, or why Chelsea's so good, anything along those lines. So we can do that over drinks later. As much as I'd like to talk about it now, we'll stay to the security side right now. Okay. So on to my next slide, if I can get my, geez, I'm having a hard time. There we go. All right, so today we are going to talk about security unit testing. Now, most of the time that I start this conversation, especially with security engineers, I get a face like this, right? Wait, I already run security tests. I've got a dynamic tool. I've got something that I've implemented. I guess you can kind of see that. Just leave me alone, right? And in general, this is right, but we're going to talk a little bit about why security unit testing and security testing on a lower level is important. We'll look at the landscape itself as to the different tools that exist and why it's important that we as developers, or we work with development in creating security tests rather than doing it in a vacuum, right? In general, the security goals do not always equal development goals, and you can read through this slide. But basically, the existing tools that are out there don't always fit into the development pipeline, right? How many of you have run an app scan or a web inspect before against an application? Okay, a couple of you, some sort of a security test that's done. Are those things that can be accomplished quickly with your application? I mean, how long does it normally take, those of you that have done it? Say it again? 2 minutes. Well, I'm impressed, actually, if you can get it down to 2 minutes, right? Yeah, if you break it down to small parts, you're right, you can. Typically, my experience with it is coming from the consulting side, and when I point one of those tools at a generic application, I'm surprised if it accomplishes anything in less than an hour. Right? It may give me a couple results, but it has to spider the application. It has to identify all the endpoints, then tries to throw the kitchen sink at everything that's out there. And I understand why that works from both a security and a development perspective. Right? I'm attempting to identify vulnerabilities, but that's a really hard sell to development if I'm trying to push something into the test-driven development lifecycle. Right? Something that can run quickly, give me results, and then we can move on. So the mantra for today is flaws, not exploits. It's great that those security tools can identify exploits and it can identify vulnerabilities, but my proposal here is that the way they are going about it is not necessarily the smartest way, right? So we're going to concentrate more on flaws, on finding flaws in the application and not necessarily exploiting those flaws. And we're going to do this through a series of I'm calling them security bots, right? Really, it's just unit tests, this low-level unit tests that we're running against the application. But we'll define where those actually fit and how we can implement them. So we're going to go through a number of different items. So first things first, right? We're going to talk about the current security testing tools, the landscape that's out there, what exists for application security testing specifically. So we're not talking about your Nmap or your Nessus scans or your vulnerability scans. I'm talking about application security, how we identify flaws in code and the tools that exist. And then we're going to talk about, from the development perspective, what sort of tools or frameworks the developers have to identify those same things. And then we're going to combine those two and create our security unit tests. We're going to talk about the requirements that are needed. So what we need from both the testing tools and the testing frameworks to actually identify security vulnerabilities or security flaws, and then the approach that we need to take if we are to implement that into a development operations lifecycle, into the DevOps pipeline, right? And then finally, I'm going to show you Sputter. This is a tool that we developed internally for running security unit tests. I'll talk about why we developed it and where it fits in our pipeline as well. So, okay, so we do have some people that are familiar with current security tools, and I don't know why that's not working, so I'm going to drop it. We've talked about this a little bit already. The current security testing tools that are out there, be that AppScan, Web Inspect, or even the source code analysis ones, these are the static tools that are looking at the source themselves. They have a very specific niche that they are filling, right? They're attempting to identify vulnerabilities, and then anything that is flagged as a vulnerability, they attempt to reduce any false positives that exist there. So if I identify something, I want to make sure that I have 100% confidence that it is a vulnerability before I turn around and report that. This is great, and it gives me a report as a developer, but a lot of times it's not all that actionable, right? These tools are typically driven by compliance needs. So security comes to development after we've released a product, and they say, all right, we need to run a security scan on it, and we're going to use AppScan to do that. It runs for an hour or 2 minutes apparently, but it runs for like an hour, and it just spits out a bunch of results, but then development is responsible for taking those results and figuring out where those vulnerabilities exist in the code and then fixing those vulnerabilities. So it's not necessarily the most time sensitive process. It takes a while to actually get through it, and there's a lot of manual steps that are involved. And that's exactly what we don't want when we have a continuous development pipeline, when we're trying to release software quickly. So if you look at the current landscape of security tools in the DevOps space, this is what you've got, right? In the background, you may have a couple tools that are there, but in general, the pipeline, the tools that exist aren't there until you get to the very end, right? Where you're actually able to build the application. And this is a problem. If we're trying to fix code and we're trying to quash security flaws, we need to do that sooner rather than later. The cost is exponentially less the sooner in the life cycle we actually take care of it. The static tools that exist attempt to do this, by integrating with the developer IDE. Right? They've often got plugins that are there that sit on the developer's desktop, and I can run a security scan as I develop my code. The problem there is it really does push more into that testing and maintenance step within your SDLC, mainly because I have to be able to fully build the application for those static tools to identify vulnerabilities, right? They do source to sink traces. They may be able to pick out a few things. They run a regex or something else, but it is very much so focused on the later stages of an SDLC. So what we want to do is slowly push further up. I mean, there's things that we can do in the analysis phase, whether that's threat modeling, we write security requirements and things like that, but at some point we have to verify that those things are in place, and that's where the tools come into play. So the two different tool sets, first of all, you've got your dynamic tools, right? Your app scan, anybody here has used Z-Attack Proxy or Burp Suite Pro before? All right, we got a couple hands. If you haven't implemented those and you haven't handed those to your developers or even your QA testers, right, that's one place that you can start because those tools are readily available and easy to use. Burp Suite Pro, like the professional license, is very inexpensive compared to an app scan or a web inspect, like the more commercial versions. But basically, these interact with the running application to identify vulnerabilities, right? You point them at an application, it sends a series of payloads, get something back. Typically happens later in the SDLC, but it's basically just a glorified quality assurance integration test. And security people don't necessarily like to hear this, but in general, a penetration tester or even those high-paid consultants that you bring in like us, we're just QA testers. We just happen to be very specialized in what we do, but we really just do quality assurance work. I remember back in my college days going to a class and talking about software engineering. We talked all about quality assurance, and everybody's like, oh, this is so boring, this is so boring. And now it's everything that I do, realistically, right? I take payloads, I send them an application, I look at the results. That's it. So you need to get your quality assurance guys involved in this process if you haven't done that already. So that's the dynamic tools. The static tools actually understand source at some level, right? So it's implemented by the build engineers or something like that in a development pipeline earlier in the SDLC. So hopefully during some of the more the earlier stages when you are building or you're putting things into a development environment or a staging environment rather than when it goes into production. They're typically a cross between functional and integration tests, but like I said before, they do require a full build of the application to truly identify security vulnerabilities. We'll talk a little bit about why this is, but for now, just know that it is basically an integration test, and we've got to have a full build to be able to identify the security issues. Strengths. There's a bunch of strengths here. I'm not saying that we need to throw these away, right? They meet the compliance needs. They give you that big green checks box. If you think about OWASP or some of the federal, the financial regulations, healthcare regulations that are out there, they all ask whether or not you test for the OWASP top 10. They do a good job here in doing that. These are really good to put at people that don't necessarily understand the code. So it attempts to generically identify vulnerabilities based on known exploits, known vulnerabilities, known payloads. Most of them have started out at some point as a regular expression engine, being able to see whether or not the payload that you sent popped back up in the HTML. That's an easy way to identify cross-site scripting. And even Sputter takes advantage of this. But there are some weaknesses involved, right? False negatives is a huge one. especially on the static analysis side, depending on the framework and language that you are using, running that static analysis tool may or may not be effective. And the last thing that we want is to spend all this money. I mean, cost is a huge problem here when we're talking about Fortify or AppScan source and actually deploying that across an organization. But if we're spending all this money, the last thing that we need is simple vulnerabilities to pop up in the code when we've already paid. We're looking at, some way to actually reduce the vulnerabilities that are being pushed into our applications. The fact that there's no human component in a lot of these tools makes it very difficult to identify full classes of vulnerabilities. So authorization and authentication vulnerabilities especially. If you think about privilege escalation, it's very hard for an automated tool to say, hey, I know that an administrator should be able to access this page, but a regular user should not, right? Without some sort of human interaction saying, this is an administrator account, this is an administrator page, the tool's not going to know whether or not they should be able to access it without certain tokens and other things. Cost, I brought that up already. The thing I want to say about cost is it's not just your initial upfront cost, like licensing cost of a tool, it's your people cost. Right? Actually being able to parse what's coming out of the tool and then actively do something about it becomes way more expensive than what the licensing fees are. And I've seen this multiple times. I've been in organizations where we've deployed both, Fortify or AppScan source, and realistically, the number of consultants, the number of employees that actually had to drive that effort was way more than the licensing costs ever added up to. Okay, so those are the tools that are currently out there. We shouldn't throw them away, but we need to utilize them better. Unit testing frameworks. All right, how many of you in here are developers? Sweet. All right, well, this is a good mix then. How many of you here write unit tests for everything you do? Okay, I'm not raising my hand because I definitely don't, right? In most of the code that we analyze as an organization that I've seen as a consultant over the years, you want to know what the average number of unit tests is on code that's turned over to us for security analysis? Yeah, it's a big fat 0. We do walk into some organizations where they are more disciplined and they're more grown up from a software engineering perspective, and they will have some unit tests, but even those organizations, they have all the legacy code. No one ever goes back to write unit tests for legacy code. It's more of a mixed bag. They're like, all right, we're just going to throw this into production, and then what happens when there's a security flaw? There's everybody sends a bunch of emails, they run in and they go fix it, but they never write a unit test to go around it. So we find the lack of unit tests disturbing at some level, especially because all of the frameworks and languages that are out there support unit testing. They give us the ability to test on a low level, like everything from a low-level unit test, functional test, to a complete integration test. Now, part of the reason that I got involved in, more security unit testing, especially working in an application security company, is because of a need that we had. We have a whole suite of intentionally vulnerable applications, like ways to do things bad that we've written that are out on GitHub that we use for training purposes. We hand them to developers and say, hey, look, you should be able to identify cross-site scripting in this, so go identify it. And at some point, we wanted to actually test whether or not a developer could fix that code, right? They have to fix it and they submit it back to us via Git. We've got a whole continuous integration pipeline. We're running Jenkins, and we've written unit tests to actually check to see whether the students have learned what they should. So in this case, right, there's all of these different languages that are out there that support unit testing. Our initial stab at it was to write unit tests in each of the frameworks as we were rolling out the code to actually test for the security endpoints or the security vulnerabilities that we knew about. And so what I wanted to do is kind of step through the different options that are available in a couple languages, right? I mean, if you've done unit testing before, this will be familiar to you. There's a lot more resources out there, so this is just a general overview. Don't expect it to be a complete, listing of all the functionality of unit testing in Java Spring or in .NET MVC, because there's a lot of options that exist. But these are the gotchas that we found when we were attempting to write unit tests in these languages. So first of all, Java, right? Specifically Java Spring, because that's what everybody seems to be developing web apps on nowadays. The framework provides all sorts of tooling for us to run a unit test. Everything from, hey, here's a mock controller and I can test to make sure that it's adding two numbers properly, or I'm going to run a full integration test and have it, I keep picking that up and it's not working, and have it interact with the database, and I can identify a SQL injection vulnerability because I can look in the database and see what's going on, or I can actually send the code to the application itself. Java made it fairly easy to spin up an instance and actually test security issues or security flaws with the application, but we still had to jump through some hoops to get to that point. .NET on the other hand, it has, again, frameworks for us to use. We can spin up, it'll build mock controllers and low-level unit tests for, testing different functions. We mock out the different components using both built-in and third-party frameworks, but we did run into a huge issue here, right? Whoops. As it turns out, the unit testing frameworks that are in .NET, they don't allow us to actually access the HTML. Now, why would this be a problem for a security test? What can't I do if I can't identify HTML for a web application? Say it again? Yeah, cross-site scripting is huge, right? I mean, this is one of the main vulnerabilities that's out there in the OWASP Top 10, but if I can't actually look at the HTML, I can't test for cross-site scripting. It also eliminates things like the ability to, see what the response is for SQL injection and other things. I could get a status code, but I couldn't actually get, a full HTTP request response. So it's things like as simple as tracking authorization and session cookies and things like that are very difficult to do. So we'll talk about how we fix this in a little bit. But it's basically, there are some limitations with the testing frameworks that are out there, and you don't necessarily find them until you're specifically trying to accomplish some task. Django, on the other hand, like the modern frameworks, so we like to call them the hipster frameworks, Django, Node, Rails, right? They typically have a fuller suite for us to run from and to use. So in this case, the test client that is built into the unit test allows full access to the HTTP request response, including HTML. So they intend for it to be used in the manner that we are going to use it when we're building a security unit test. So the summary here. Unit tests in general focus on low-level functionality, right? If we're being semantic about it, a unit test, we're taking down the code to the smallest unit that we possibly can to test it. So typically, and what Sputter and security testing is more of an integration test, but the integration test frameworks provide us with that full level functionality that we need when we are going to write a security unit test. Okay. So now that we've talked about, the security tools that are out there, we've talked about the testing frameworks that exist for developers, what we want to do is mesh the two, right? And why do we want to do this? I mean, this is typically what a security test is like, right? When we look at our application, right, we need to inoculate that application against security vulnerabilities. And what's the best way to do that? I mean, is the best way really to take those testing tools and throw every exploit and attempt to exploit the application completely before we turn around and fix it? I mean, that works, right? Make somebody as sick as they possibly can, and they're not going to get that same virus ever again, basically because they lived through the experience once. I mean, I'm kind of taking a healthcare metaphor here for, inoculating our application against something that is bad for it. right? If we write a security unit test and we limit that security unit test down to the, just the flaw that we're attempting to identify, if we're, again, flaws, not exploits, right? If I can identify that flaw, there's no need for me to exploit the application, and I can inoculate, I'm having a hard time with that word today. I can inoculate that application against the full exploit. It doesn't need to become a full vulnerability if I know that the flaw exists. So that's the whole idea behind these security unit tests. Right? We need a functional application, so there still is going to be some requirements here for building out the application and being able to test for it. Right? Something has to exist for me to test. This includes mock data, full HTTP request response. So I'm not only talking about the application itself that's running, but I'm talking about the test framework that I'm using that's interacting with the application. I've got to be able to see that full rendered HTML, the full request response. This is really easy for the tools that exist that are out there, right? So for AppScan or Burp Suite Pro, if we're running one of those, we're interacting with the live application. It's very easy for it to see all this data. But when I'm spinning something up inside of my DevOps pipeline, this is what I've got to have. If I don't have it, I can't identify the same flaws. In addition, I've got to be able to maintain authentication state both on the application side and on the client side, right? And this again falls back to those full vulnerability classes that depend on this functionality, right? If you're attempting to identify insecure direct object reference, you've got to be able to know what is authorized and what's not for a given user as they log in. Now, part of what we're doing here when we talk about this and we talk about authentication state and unit testing is we want the developers to be involved in writing security unit tests. At a minimum, right, the QA department, right, they should be doing it as well. But if the developer's involved, we can minimize the amount of tests that we actually have to run. We don't have to run a full security testing tool to identify those flaws. We can limit it down to specifically what the developer knows about the application. I've always maintained that the best application security testers are developers, right? People that understand code, and the best testers of your application are the ones that wrote it. Really, they are. So in this case, right, we've got to have authentication and authorization functionality, and we've got to have consistent responses. So if I send data to the application, it actually has to store that data so that I can test for it at a later date, whether that's access into the database and I'm pulling something out there, or a different page that I can view, a different XML endpoint, right? There's all sorts of ways that data actually has to persist. But realistically, that big one is it's got to be functioning application and it's got to have test data in it. I mean, these are the same requirements that you hear from QA all the time. Again, your security consultants, your security testers are just high-paid QA testers, right? I'm not trying to disparage anyone, that's just the case. All right, so for Java Spring, I've got a couple examples of how we've actually accomplished this. Again, this is with those intentionally vulnerable applications that we've written, So in this case, we're using a Spring Boot test framework to spin up a full environment that we can then interact with, right? We're using MoneyX. There's a test template that we've written. MoneyX is the name of our Java Spring vulnerable application, right? So we're running an injection test, but in this case, all we have to do is specify the different class files and tell it we want a web environment spun up, and it does that. It provides us with a random port, and it's fairly easy to access and to talk to it. So in those application class files or the configuration files, it actually spins up a database as well. So it makes it very easy to interact with. .NET, on the other hand, right, the whole fact that I can't access HTML via the unit tests means that I have to go and hack something together like this, right? I have to use IIS Express and launch it behind the scenes to interact with in order to test for security vulnerabilities. Yeah, it's kind of a pain, but once you figure that out, it works just fine. But don't even get me started about trying to port this over to Mono and Linux, because that's a whole another bag of issues. If you want to do that, let's talk about it, but we can do it over drinks, because that's the reason I have gray hair, right? It took a long time to figure that out, and .NET Core didn't really help that much. That's all I want to say. So that's, ASP.NET. Again, those hipster frameworks, they make it a lot easier in this case, right? I can even just specify fixture files that it loads up in the test that I'm concerned about. The client itself maintains the browser, and it gives me a mock browser that I can use. So the lessons that we learned in building these is that each language takes a unique setup. Right? And each framework within the language may be different as well. So just because we're using .NET doesn't mean that it works in Linux or on Mac like it does on Windows. I mean, that's probably a fairly obvious statement given that it is .NET. But we see the same problems with Python, and we see, some of the languages as you port from environment to an environment, it makes a difference. So just because I built something on my local development machine doesn't mean that it runs in AWS the same way for us to integrate it into that continuous integration pipeline. Right? This is a combination of dynamic and static security testing. We're using the developer's knowledge of the code to actually target our security tests to specific vulnerabilities, specific endpoints. We can do it really quickly because in my case, right, I've got an intentionally vulnerable application. I know where all the security issues exist, and so I don't have to scan every single endpoint for cross-site scripting. I know it only exists in 2 places. It means that the number of security unit tests that I had to actually write went from 100 when it comes to cross-site scripting down to 5. Right? And so I can do this very quickly to report back whether or not a student actually could pass the course. The other thing that we found, again, the gray hair, it takes as much time to actually set this up as it does to write the unit test. It takes longer to actually identify what we need to write the unit test and interact with the application than it did to write the unit tests themselves. We all know how to use Selenium and a web client to interact with an application, right? Programmatically, that's fairly easy to do, and there's a lot of examples out there. There's a lot less examples of how to actually stand up a fully functioning .NET environment in mono for testing purposes. So the time invested becomes more about, hey, how do I actually meet those requirements than it is how do I actually write the tests. But it doesn't mean that we don't have to talk about the approach on security unit testing and what we do once we have a fully functioning environment. What we want to do here is realize that just because we wrote one security unit test doesn't mean that the application is impenetrable. Right? We've got to test each endpoint, parameter, vulnerability, and possible vulnerability payload, right? That sounds like a lot. And this is why we came up with the whole robot approach to this, right? We want a little bot that only knows about one vulnerability payload, one vulnerability, one parameter, and one endpoint, and it goes and tests that. And then it can give me an assert on whether or not that's actually succeeded or it's failed. But math is hard when it comes down to it, right? If we have 10 endpoints and 10 parameters on each endpoint, 10 vulnerabilities for each parameter, and let's just say 5 payloads per payload. Well, that's not right. 5 payloads per vulnerability. That's 5,000 tests, right, that we have to run, right? And that means it's going to take a while. This is exactly why AppScan takes as long as it does, because it identifies all of these endpoints, all these parameters, and then it throws thousands of tests against the application. And oftentimes it's doing the same thing over and over against the same endpoint because it doesn't necessarily understand how the application is built. Again, your developers, those that wrote the application, know better how to test that application than anyone else. So if we are writing a security unit test, right, we identify the endpoints, the flaws, the parameters, the vulnerabilities, everything that we're looking for. We just create a test, we create a bot for each variation, and then we send them loose. It sounds like a fairly easy process, but it really feels like this most of the time, right? One of the things that we've noticed is that just identifying every possible endpoint in an application, even if we wrote it ourselves, can be difficult. It's not necessarily an easy thing to do. And then you add on top of that, hey, the parameters, the way that we specify parameters for Django, it can be in the routes file. It can be, it can be basically embedded anywhere in the application. You've got to do a full-on search to figure out whether or not a parameter exists and what is a parameter and what's not, right? So it can take a long time, and oftentimes it does feel like you're looking for a needle in the haystack. But again, the developers, they built that haystack. They're going to be able to pull those needles out a lot quicker than an automated tool would. We are looking at fixing this. Well, we're looking at speeding up the process using the Sputter framework as well, where we parse through frameworks and at least give you a starting point. Hey, look, these are all the endpoints that, in a Java Spring application, the reflection shows us. So we can take that and at least start the configuration, start the unit testing for you, so that it doesn't take as much time for a QA tester or somebody that's not as familiar with the code to build those unit tests out. The next thing, we've got to create the different tests, right? Now, you can be like Chuck Norris here and do, a single assert, the application is secure, right? That's great. But in general, what we want is a series of bots, each simple, that asserts one thing. The less that we do within each of those security tests, the easier it's going to be to actually identify when those flaws occur and where they need to be fixed. Yeah, and so at this point we just turn them loose, right? Timing becomes important, how long it actually takes. So in the case of our on-demand or our training platform, right, when someone submits code to us, I can't take 5 minutes to actually run security tests, right? Because who's going to sit there and wait on a web page for security tests to come back in 5 minutes, right? I could probably do something in the background and send them emails, so 5 minutes may be the upper limit, but in general, I need to be able to run my tests and report back within 30 seconds, and 30 seconds is the high end that someone's going to wait for a little spinning ball on a web page, right? I mean, you think about how quickly we move away from things if we are doing something online. We don't necessarily want to wait. Parallel execution helps on this. Environment startup for each test becomes an issue. If I have to reset the database after every single test and I have 5,000 tests I've got to run through, that's going to take a long time to do. So at that point, we can turn these loose, we can test the application, and we'll be off and running. So finally, right, the reason that we came here, we're going to talk about Sputter. So this is a security payload unit testing repository. Initially, it was just repository, but now it's /runner because we actually have it interacting with the application. And my initial thought was, all right, we want to slim down these tests. I was before I started at Envisium, I was a security architect for a financial services firm, and I was doing a lot with their developers and specifically their QA team in identifying security flaws within an application. As a part of this, right, we had to test all of the endpoints and parameters with specific payloads, and we started to identify security payloads that were not related to your traditional QA payload set, right? You talk about a traditional QA functional integration test, and they're going to do things like, hey, the application needs to accept a phone number. So it's going to test a phone number. That's their payload that they send. But we started to flip it a little bit and say, all right, we know that we don't want to use, we're going to use the FuzzDB list of cross-site scripting payloads, and we're going to send those at the application and make sure that it responds appropriately to those as well, just like it would a phone number. So we started building up this list of payloads that we could use for security QA tests as opposed to just QA tests in general, right? But what we found, and what we found with the intentionally vulnerable applications, is most of the security payloads that are out there, again, are very exploit focused, right? And what were we saying? Flaws, not exploits. Just because one version of Internet Explorer is vulnerable to cross-site scripting in this one variation doesn't necessarily mean we need to test our application for that one vulnerability, right? Not only do most developers probably, or most of your users not use that version of Internet Explorer, but it doesn't really give the developer much knowledge as far as, or much information about, hey, there's a security flaw that exists and this is what we have to do to actually fix it. So with our intentionally vulnerable applications, we wanted to speed up the security integration, and we wanted to limit the number of tests that we actually had to run. We know where the vulnerable endpoints are, but we want to limit the number of tests that we actually have to run so we can report back even sooner. And this is the case with most continuous integration environments. We don't want to run more tests than we have to. Yes, we want to make sure that it works and that it works as expected, but each extra test that we run in that environment is less time, just adds to the amount of time that it takes to deploy something to production and get new code out there and get functions and meet those business requirements. All right, so this takes us back to the hash sign. Now, I'm going to go back in my past. We're going to do story time with Seth here for a little bit, because that's what you all came for, right? You wanted to hear my stories? No, okay. All right, where are you going to get that anyway? So back when I was in high school, this was before we had the internet, right? Yes, I am that old, that's fine. The administration at our high school decided that they were going to implement a new system that reported to parents when when students missed class, right? And how did they do this? The piece of information they had about every student and every parent was their phone number. So they bought an automated system that they would load attendance records into that would call each number and report whether or not the student associated with that number had missed class that day. But it only called when you actually missed class from a student perspective. Now, of course, us being enterprising and the fact that we didn't like this and we were dialing BBSs and war dialing at the time, we can talk about what that is if you don't know what it is, but we'll do that later. The system would also report like announcements and things like that. There was a number associated with it that you could call up and actually put your phone number into, and it would tell you whether or not you had any absences that day. But there was one thing that we noticed. You'd call up the number and you'd push 1 and it would say, oh, the announcements for Logan High School today are, and it would just a pre-recorded message. It was just a voicemail system when it boiled down to it. You push 2 and it'd say, okay, enter your phone number, and then it would tell you whether or not your student had missed things. And of course, what do? We try every other number on the keypad, and we hit the hash sign. What do you think the hash sign actually did? Yeah, it said, please enter your admin code. Okay, so what do you think we tried? 0000? Incorrect. Please enter your admin code. All right, 0001. Nope, still incorrect. All right, there's 5 of us. There's only 10,000 possibilities. We're high school kids. We have nothing but time. How long do you think it actually took us to figure out what that admin code was? Yeah, it was about a day. We didn't have anything else to do on a Saturday. We divided it up. We wrote down a whole bunch of numbers. The first one I think we discovered, it was like 5123, right? So it took us, we had to go through about half those numbers to figure it out. When somebody started up at the top, somebody started at the bottom. And once we figured it out, there was a number of different options that we could do, or the number of different things that we could do with that voicemail system. You listen to the menu, and number 1 was record a new announcement. Number 2 was something else. Number 9 was reset the system. Now, what do you think happens to memory when we reset a system? It's ephemeral memory, right? Anything that gets loaded into RAM, it's gone. So we discovered that, they loaded the system, they loaded the attendance records in there at about 3:15 in the afternoon after school got out. If we were to log in at, say, 3:20 and hit number 9, how many calls do you think it would make that day? Like 2, right? And so we used this for years, right? In the last 2 years that I was in high school, we would log in, every time that we skipped class, we would just log in at 3:15 or call up a friend and say, hey, can you reset the system? I don't want my parents to know that we skipped today. All right, beep. And it would, reset the system. It was great, right? It made it so that we didn't have to worry about whether or not our parents knew that we were skipping class, and we'd come up with some other excuse at the end of the semester to say, oh, I must have been late that day or whatever, right? So why am I talking about this? comes back to this single digit, right? The single number, the single security flaw that we were able to identify because we sent one character to the application. In this case, this voicemail system. Now, this doesn't mean that we didn't exploit it, because we did. We actually took advantage of the fact that it gave us the login prompt, and we could put in the code numbers and we could do other things. Yeah, that's fun and all. But realistically, the security flaw is that the administrator login page was available to unauthorized users. That's really what it boils down to. And it was because we could put in a single character. So we're taking the same paradigm, right? The single character into the security, into the sputter payloads, right? I don't necessarily care what the exploitation factor is after I enter that single character, but I care about what that single character is, and that's what I want to report back to the developer to actually fix in the code itself. So if we look at XSS payloads from FuzzDB, right? And this is just download straight off the GitHub page for FuzzDB. And I've done this with a number of different payload lists that are out there. XSS is by far the easiest because there's thousands of payloads that exist. But in this case, how many of these do I truly need to send to my application to know whether or not it's vulnerable to cross-site scripting? Right? Realistically, in this list, this is only 16 of the 150 that get sent. But realistically, I need to send a single quote, I need to send a double quote, a greater than sign, a less than sign, a percent sign, and an ampersand. That's it. Because if the application responds with that in the HTML anywhere, I know that I have an encoding problem, right? I focus on those characters. I know that I have an encoding problem around a double quote, and I can tell the developer to go fix that. And not only can I tell the developer to go fix that, I can tell them the endpoint and the parameter and the string that actually caused that encoding flaw. I don't have to go to the line number in the code itself to actually tell them where it is. That's enough information right there for them to actually go fix it. I don't need to do a pop-up button, right? I don't need to do an alert XSS. I don't need to execute JavaScript for this, for the developer, or for me as a security person to know that there is a flaw that exists and that the security flaw needs to be taken care of. Right? And that's the whole idea behind the payloads that exist in Sputter, right? We use a list of characters that's bad. We generate some random characters around them so we can actually identify it. I mean, it's going to be really hard to identify one errant double quote in HTML, right? If I don't have something around it that allows me to identify it properly. So in this case, right, it's just a regex expression that I'm looking for in a string that's being returned from the application, and I can tell that to a developer, and I can get that information back very quickly. I don't have to execute a full web browser. I don't have to execute Phantom.js to look and see whether or not a pop-up box occurred, because I didn't have to exploit the vulnerability to know that the security flaw exists. So remember, flaws, not exploits. So let's do a quick demo of, all right. Can we actually see that, or is it too small? All right, so I got a payload demo here. That's about as good as I'm going to get right now. This one's just, easy to actually identify. In this case, I've only got 5 of those payloads that I'm loading up, right? I've distilled down the characters to something that's interesting to me, at least for this application. But in this case, we're doing a search against a vulnerable Django application. It's running in the background. And I've got 5 payloads that are sent, and you'll see that it's not filtered for any of those for the queue parameter, right? And this is actually just what's reporting back. Like, this is all based on asserts behind the scenes. So these are actually error messages that are being printed out to the screen. So it's very easy for me to implement this in my development pipeline, because if I run it, I get these 5 errors back, and I know that it didn't compile correctly. It did not build correctly when I run that test. And what you'll notice is that the payload values actually change from iteration to iteration. This helps when we're looking for things like stored cross-site scripting. But again, we don't have to scan the full application to look for stored cross-site scripting. We're using the developers to write our unit tests. We know exactly where that information should be coming back out, right? If we're throwing that into an account value or a first name field, we know exactly in the application where that first name field is displayed. Let's not scan the whole thing and spider the whole application looking for that. Let's look specifically in those locations. And we can even take it a step further. We could look in the database itself if we wanted to. All right, so that's just the payload generation that happens on the fly. There's a library that you call within Sputter that actually pulls that back. And I don't think I mentioned this. Sputter is written in Python 3 right now. Well, right now, it is written in Python 3. We're not planning on moving to anything else, just because it does give us the harness to do everything that we want to pretty easily. Okay, so that's payload generation, very easy. And it happens behind the scenes, like if you specify that you want to do an injection test, it'll go in and pull the SQL injection values, the SQL injection characters, and insert those into the payloads for you, and then iterate through them. You don't necessarily have to go and do anything specific to instigate those payloads. If you do want to add payloads or add some characters, you got some special character that you think is more important than the others or what we've currently got specified, it's easy to go and add that to a text file somewhere, and then those get sucked in to the payload creation, right? Test generation for Sputter. I wanted to make this automatic, and I still want to, but it didn't happen before I got here. We are in the process of working on it for both Django and Flask applications. Those seem to be fairly easy, and then we are going to add more to it as we go on. At least, at the very least, pulling out those endpoints and maybe some of the parameters so we can start the unit test creation. But what I want to show to you is actually how to create the configuration file. It's fairly easy. If you've written unit tests before, it is pretty easy to write a unit test as well, but this does take some of the guesswork out of it. This is a configuration file for I think this is MoneyX. So this is the Java Spring application, and it's all just JSON objects. This has been the easiest way for us to, dump results and then also to parse configuration files. The one thing that you do have to recognize is you manipulate it if you don't put the commas in properly. If it's not properly formatted JSON right now, it just borks out. We are still flushing the tool out, and so the more that you actually, play with it, the more that you can, you'll recognize how it actually works, but we will add some of the error checking and things like that to it as we move through it. But what you'll notice here is, there's different endpoints. There's the login endpoint that doesn't require authentication. We're testing the username and password parameters. You do have to specify things like the domain, the protocol that's being used. So it'll do HTTP or HTTPS, doesn't really care what it is. We're just using Python on the back end. And then the tests, right? We can specify which tests we're actually running. There's 5 that are built into it right now. We're adding to that as well. I have a full suite of tests that we've used that we've built for the intentionally vulnerable applications, and we've just been porting those over as we're starting to use Sputter rather than the built-in unit tests. Right, so make payment. The tests, it's a little innocuous right now. It's just a bunch of 110011. That basically it's bit flipping for one's an XSS test, one's test for SQL injection, one's test for access control or insecure direct object reference, CSRF, right, CSRF. It's fairly easy to actually do. But the thing that we've noticed is it's a lot easier to go in and do a block of JSON than it is to go write a full unit test for each of these endpoints. Right, it only takes me 5 seconds to actually go in, copy the block, make the changes that I need for a specific endpoint, rather than building a full unit test for each of those endpoints. That's the whole idea, right? We're trying to combine what a developer knows with what a security testing tool should know and make it so we can do that quickly. All right, so that's the configuration file generation. Sputter testing, it's really easy. It's all command line. You saw me do it there with that one instance. So it's callable from Code Pipeline and Jenkins. It decreased the cost of building the unit tests and actually running the unit tests. So let's run one of them here while we're talking about it a little bit. Let's see. Okay, so this is the MoneyX Well, let's do Django. Django is longer because I've written more tests for it, right? The configuration is pretty long. But what you'll see is it just pops up. The only time that you see the equal greater than sign or errors, right? You know, payloads not filtered for parameter text. It's doing SQL injection tests for various different things. You can see that it, 26 of 26 passed. That means that there's like 10 or 13 different payload characters for SQL injection right now. But when it passes, there's one that actually failed, caused a database error in parameter email. We're queuing off of things like a QA test would, right? And so a unit test, we're not necessarily looking for full exploitation of injection. Again, what we're looking for, hey, did you cause some sort of a database error? Did we see something in there that maybe we shouldn't have seen? And if we do, then we flag it, right? This is a flaw, this is a security flaw, and the developers need to go take a look at it. Now, in some cases, you'll see things like that, right? 26 of 52 passed. There were errors because of something outside of a database error being returned. That's still interesting to us, but I don't necessarily want to flag that as a, hey, this is a critical vulnerability, and we're going to stop the continuous integration pipeline from occurring because maybe like they fixed it by doing an isInt or something like that that's causing a different error to occur rather than an injection error, right? No authentication, right? Those are access control tests. I think we're about done for Django NV here, or we should be about there. Once it completes, it actually, there's the log that's on the screen itself, but it also dumps a results file out that has all of the tests that were run with timestamps and everything else that you would expect to save with your unit testing artifacts as you push things through. So hey, this is when it was actually run, this is what was actually done, and whether or not it passed and why it passed or why it failed, right? Let's see if I can actually... Right, we'll take a look at these. So there's our cross-site scripting vulnerabilities that were popped in there. Those are passes for cross-site scripting and SQL injection on different parameters. Again, more cross-site scripting errors. Let's see, I wanted to get down to one that was actually an error rather than a full-on cross-site, like a failure. Yeah, there you go. Okay, so in this case, right, I sent a payload with a tick mark in it, right, or a single quote. It caused an unknown error in parameter DOB. And it's probably because we're doing some sort of bait parsing on the DOB parameter. So it's causing an error to occur. That isn't necessarily a security error. It's probably something that we still want to know about, though, when bad data is sent, how the application's actually responding to it. But we're not going to stop our continuous integration pipeline because of that error. So that's it. I mean, so that's how the sputter actually works, how it dumps things out, and what you can expect when you're running it locally. I would be interested in people using it and letting me know. If you are interested in a tool like this, let me know, or even tearing it apart. I don't care if you just want to take the payloads or something like that and take a look at it. I am depending on other people as well, right? I've gone into the FuzzDB lists. I've gone into Daniel Messer's sec lists to actually build these payloads out because those resources exist. And so I want it to be a resource for other people as well. So into the future, this is what our next iteration is going to look like, right? Further payload options, we're going to keep refining those. Additional vulnerabilities, I've still got at least the rest of the OWASP top 10 that need to be implemented. Those should be out, and we've got them in the test branch right now. I just haven't ported them over to the master branch yet. Testing speed is a big one. You saw how long it was taking the Django NV results to actually run through. It's all single-threaded right now. I want to make it multi-threaded. Part of this is we need to start up the application behind the scenes and shut it down. Using Sputter instead of an outside source. Right now it is an outside source. Generation, we want to do the automated analysis of the different frameworks. It's fairly easy to do regexes and pull some of that information out. The faster that we can write the unit test or at least flush that out for you, the better off we're going to be. Obviously more languages, more frameworks, support there. Looking at Burp Suite Pro or ZAttack proxy log files and state files to actually push that into Sputter and help with the configuration generation. So that's the plan. All right, the summary of what we talked about today, current security testing tools are great, but they're too generic. So you need to write security unit tests that are specific to your application, and you can use Sputter to do this. But above all, remember, flaws over exploits. We can identify flaws and we can fix them quicker if we go that route, and then if the developers are involved. So use Sputter. Let me know if you run into problems with it. I know I am out of time. They have been flashing me numbers. Are there any questions? Yes?
So you mentioned that developers are the best when they write the test, but sometimes when they build the application, they have blind spots, right? So how do you get around that?
They say that again?
So they might have blind spots when they write the application.
Yes.
They don't remember that they just got what they got.
Yes.
So how do you get around that?
Okay, so the question is, how do we get around the blind spots, like a developer forgets that they wrote an endpoint or they wrote a parameter? Part of that is if we go back to the future, what we're going to be doing is sorry, that was two back, is actually the automated analysis. That's going to be the only way that we're going to get around that. Or using a spider, like the Burp Suite Pro has a spider functionality, and pulling that in, right? We've got to look at other ways to actually see how the application is structured so we can pull that information in and generate those unit tests. But I'm with you, right? I get something from a developer, I can go in and I can scan through the routes file, but if there's something somewhere else, I've got to have an automated way to test that. And that's, partially what we're tooling currently, right? So the idea is that we're going to start to uncover that, within that next iteration. All right, any other tests or any other questions, tests, whatever? All right, great. Well, hopefully it's useful to you. Thank you for attending. Hopefully it was entertaining. Please, send reviews or comments. Tell Black Hat that you thought I looked funny and I shouldn't be back. That's fine too. I don't really care, but I appreciate it. Thank you for your time.